Ancillary services need to be adapted continuously to the increasing complexity and demanded flexibility of modern electric power systems. In the traditionally regulated energy markets, ancillary services were usually provided by integrated electric utilities. The transition towards smart grids requires a transformation of the traditional energy markets from hierarchical-based power systems towards open distributed smart power systems. The smart grid integrates the operation of all connected users, electricity producers, users, and prosumers in order to ensure a safe, efficient, and sustainable delivery of electricity. Challenges related to the provision of ancillary services in smart grids are mainly due to the characteristics of these systems involving, among others, new types of market participants, renewable energy sources, and distributed energy resources. Market, business, and cost models related to ancillary services of smart grids require changes on the corresponding regulatory frameworks. Future smart grids and ancillary services will have two key components: intelligence and power electronics. Intelligence will come from innovative technologies applied to components and interfaces. Power electronics will be the enabling technology for future generators, loads, and energy storage-based devices. Future provision of ancillary services and new market participants. Ancillary services markets are nowadays open to a wide range of new participants, such as large-scale renewable generation and energy storage systems, grid-connected devices like power electronics, switched compensation devices, and providers of DERs including demand response, small-scale energy storage systems, and distributed VRE generation. A number of developments in recent years in demand-side response, together with an increased research into how to emulate the ancillary services capabilities of thermal generators with renewable generators and energy storage systems, have improved the ability of these sectors to meet requirements for ancillary services. Wind turbine generators and energy storage systems are capable of providing nowadays different levels of synchronous inertial response. Inertial response has been traditionally provided by large thermal generators and large hydropower plants. Although such frequency disturbances can be addressed using fast frequency response services, synchronous inertial response can provide a more reliable and faster response. Solar PV power plants and energy storage systems having power electronics interfaces with the electric power system can provide reactive power support. Reactive power helps to maintain voltages in the system within prescribed limits. Reactive power support is especially important when there is large generation in areas far from main load centers or connected to main load centers via a weak electric power system. Distributed energy resources such as rooftop solar PV systems, behind-the-meter energy storage systems, plug-in electric vehicles, and commercial and industrial loads, can provide ancillary services to system operators through price-based incentives, often referred to as explicit demand response. By increasing liquidity and competition in the ancillary services markets, DERs can also help lower ancillary service procurement costs. DERs are allowed to participate in the markets independently or through aggregators or retailers, depending on the market design in place. Ancillary services and renewable energy. The expansion of renewable energy, especially wind and solar power, changes the requirements of the electric power system.